Okay, good morning everyone. So our lesson today is going to be nice, short, and sweet, and it's going to be to calculate the area of a triangle if I'm given the length of two sides and its contained angle as opposed to just our base and our height directly. So I've drawn here just a triangle, not a right angle triangle because that would make our lives too easy, but a triangle here where our vertices are ABC and our side lengths are labeled accordingly in lowercase letters. And if we recall from elementary school that the area of our triangle would be base times height divided by 2, or multiplied by 1 over 2. Now, what's a different way that we can write this, our height? We did a similar kind of algebraic manipulation when it came to the ambiguous case of our sine law. So here, if I give an angle C, for example, so the sine of angle C will be equal to what? Opposite over hypotenuse. And I left a gap here on purpose because in this triangle, what is that exactly? Here, of course, this only works for a right angle triangle, so I can't say little c, but I can use this over here because that's what I'm interested in, right? I need to rewrite my height somehow. So if I look at this right angle triangle that's formed from BC and over here where the height hits the side of lowercase b, I'm going to label that h, and the sine of c will just be h divided by a. And if I rearrange and manipulate this, I'm going to cross multiply, so it'll be h times 1, which of course is just h, and that'll be equal to the sine of c multiplied by the length of side a. So a sine of capital C. And now I'm going to take this and I'm going to plug it over here. So the area, I forgot to do triangle, but my area of my triangle will be equal to 1 over 2 times, now we're going to plug everything in, not just the height, but the base, and the base in this scenario is going to be side length B multiplied by side length A and the sine of angle C. So we can see, similar to the cosine law, if I have the two sides and its contained angle, I can find the area of the triangle the same way when I'm using my cosine law. If I have lowercase a, lowercase b, and angle C, I can find the length of C. And this applies for when I have the other sides as well. It's not exclusive, of course, to these letters. So triangle A, like my area, would also be 1 over 2. And if I had C and B times the sine of A, so if I had the sine of A, my mistake, I wrote C again. Right, if I had these two sides and this angle contained in between, and then again, if I had C and A, and then the sine of the angle in between them, which would be sine B. Okay, so that's the basic concept, but now we're going to apply it to this question here. So in example 1, so in triangle ABC, I've got angle A is equal to 30 degrees, side A is equal to 5, and C is equal to 7. And the question says, find the difference in area between the possible triangles of ABC. Okay, so you can already see the question's kind of hinting and directing me to apply the ambiguous case of the sine law, right? Because if there was only one possible triangle, there would be no difference. But take a minute, pause the video, and when you're ready, unpause and take it up and compare your solution with mine. Okay? Alright, so let's see what the solution is. Like I said, I always like to have a drawing, even if it's not to scale, even if it's not very pretty, of my triangle right next to me, so I can kind of visualize the question. And you'll see this as a recurring theme. It helps when you have your 3D trig questions, 2D trig questions. It just helps all the time. So this is the information I'm given. Angle A, and side C. Now, unfortunately, I can't just apply this right away, right? Because I don't have the contained angle. I need angle B in order to make this work, or I need side length B in order to make this work. In other words, I just need either this side or this angle. So that's what I need to solve. So my first scenario will be to find angle C1. And I'm saying C1 because my first potential triangle, I'm just going to label all 1s. My second potential triangle, I'll label all 2s. So angle C1, how do we find this? Using our sine law. So the sine of C1 divided by 7 is going to be equal to the sine of the only angle that we're given divided by 5. And now, rearranging everything, we're going to get that angle C1 is going to be equal to the inverse sine of this beautiful expression right here. So 7 sine of 30 degrees over 5. And it's a good idea to actually take advantage of either our graphing or scientific calculator here, because if you calculate these individually, like if I do 7 sine of 30 first, and then I choose to round, by the time I get to my final answer, the answer could be a little off, but by taking advantage of our calculators, it will give us a pretty accurate answer, and then we only really need to round when we get to our angle measure. So this is going to give me 44.4 degrees. So that'll be C1. Now, because I've got a second triangle, angle C2, much easier to calculate, right? Because it's just going to be 180 minus 44.4 degrees. So that'll give us C2, which will be 135.6 degrees. And for the time being, I'm just going to label this with my values from C1. So this is going to be 44.4. So I still don't have all the information I need, right? Neither one of these angles is the one contained, but now it's super easy to find angle B, because angle B, B1 of course is the one I'm going to do first, is just 180 minus both of these angles. So 180 minus 44.4 minus 30. Okay? And that's going to give me my answer of 105.6 degrees. Okay. And B2, I do the exact same procedure because I have to find out both, is equal to 180 minus 135.6 minus 30 degrees. I forgot my degree symbol. There we go. And angle B2 will give me 14.4. And now I finally, so like I said, I'm going to label my triangle here. So 105.6. Of course, you can draw your second triangle too, but just for simplicity's sake, I'm only drawing one right now. But now I've got to the contained angle. So now, calculating the area of triangle number 1 is going to be 1 over 2. So using my formulas from up here. So it's going to be half times the length of the two sides that I was given at the beginning, and the contained angle, which I've now calculated at the sine of 105.6. And at the same time, the area of triangle 2 will be 1 over 2 times 7 times 5, and the sine of 14.4 degrees. And our two separate areas are going to be area of triangle 1 is equal to 16.9 units squared. So we still have to write units squared. It's not like no units were given, so it's not puppies or leprechauns squared. It's still still units. And then here, for our second triangle, it's going to be 4.35 units squared. Okay? And now, the easiest step of all, just subtracting these two. So our difference, I'm not going to do delta area because having a triangle symbol would maybe confuse when we're already dealing with triangles. So I'm just going to write the difference is just going to be 16.9 minus 4.35. That's going to just give me, what do I have here? 12.5 units squared, of course when rounded. And that'll be my final answer. Okay? So hopefully that all made sense. The material shouldn't be too overwhelming. Essentially what we're doing is just using our base times height divided by 2 formula, only we're rewriting height. We're rewriting that height as the sine, or the sine of the contained angle multiplied by one of the sides. So hopefully it's nice and straightforward. Please take a look at, keep your eyes out for the other videos in this playlist. There'll be a bunch of questions from your homework, so 2D and 3D trig problems, and maybe a question or two as well with area of a triangle, but it might come later in the day just because it might be slow to upload. Okay? So have a great day, and I'll see you all on Tuesday.